This process. Good lah. Good. Excellent. Okay, guys. Anyways, let's look at the first question here. A permanent magnet is placed close to a bar of a soft iron. Soft iron means to say this is magnetic, right? What's the term called for it? It starts with the word F again.
Ferrous.
It's a ferrous metal, right? If it's a ferrous metal, the magnetic field is going to go like this, right? Wow, and then one of you guys drew the magnetic field wrong also. Okay, anyways. So if the magnetic field is going like this, it means to say this will be what polarity, guys? The immediate opposite of the magnet should be S. And this will be north, right? How do I know this? Number one, they are not repelling each other, right? So no way it's going to be N, right? A magnet can't repel an iron bar, right? So impossible. Number one. Number two is you observe the magnetic field. The magnetic field will go in here and come out here, right? The magnetic field will go in here and come out here, right? When they're connected. If they're going out like this, that means to say this must be North Pole, ma. 啱冇? Nicole 姐，对吗? And thus, your P is S and your N is, sorry, your Q is N. I 怎么会 repel 呢？ I know iron bar 没有粘在一起 is because they say they place it close to the bar magnet only one. Yes, 如果 okay, look at this. This is a magnet, right? Right. Are you telling me that when I place it very near, it's gonna start? What? Oh, you have by scale some more now. Okay. In terms of the accept it as this, the bar magnet will attract. Okay, it's not gonna repel. Okay, then this one. What is EMF of a cell? Electromotive force, like I said, there's a formula to it, right? V is equals to work done over charge. From here, you can already bullshit your way through already, right? EMF is the work done to drive 1 coulomb charge around the circuit. You see which one has it. Yeah, the only one, energy, which is this one, work done. Gain per unit charge, which is this one, as the charge passes through the cell. They're basically saying this, the charge is going to pass through the cell here, right? Something like this, like which is in line with the definition again, right? Electromotive force is the energy needed to drive 1 coulomb charge around the circuit. Something like that, right? Should only B is the only one answered, right? And then this one also, people, they get it wrong. You're supposed to compare the length first, then only the area, right? This one here. Diameter the same as area, my friend. Well, it's definitely not, right? You're supposed to compare the length first. When you compare the length, if let's say right now the question is a piece of wire is 40 cm long and has a diameter of 2 mm. Let's assume it's A, guys. Then after that, the resistance is 0.3 amperes. Sorry, 0.3 ohms. Which wire has a resistance of 0.15 ohms? Okay, if I compare this with this first, we compare the length from 40 to 20 cm, the resistance dropped by half, right? Which means to say the resistance from 30 ohms dropped to 0.3 ohms dropped to 0.15 ohms, right? Just by the length itself. And right now the area is changing lagi, right? So A is definitely impossible already, right? It's out already, right? And then same thing for this one also. The resistance, the length dropped double, the resistance already reached 0.15 already, but the area changed again. So this one also impossible, right? Hey, anyone don't know what I'm talking about? This one is important, by the way. If you don't ask, guys, that's about it already. You're going to be at the mercy of other people asking, clarifying your question. If you don't know, you better ask now, guys. 100% absorption rate again. So now that I look at it right now, so the only logical thing is the 40 cm is supposed to go to 80 cm, right? Because when you double up the length, the resistance will double up also, right? The 0.3 ohms will go to 0.6 ohms, right? Right. Then we have room to change it, right? Because right now, if let's say this is area, when you double down the area, you quadruple down when you double down the radius or diameter, you're going to quadruple down the area. You see, like this one, here is double down, right? But the area quadruple down, it quadruples down because the formula is pi r square. You can do your calculation at home yourself and you'll notice that when I double down my radius or diameter, my area will quadruple down, right? Which means to say, if I look at this scenario here, and I know that this is 1/4A, right? From from area go to 1/4 area, what's going to happen? Will the resistance increase or decrease? The resistance will increase, meaning to say the 0.6 ohm will actually times 4 and make it 2.4 ohms here. So I know that C is actually unacceptable also. It's not the correct answer. So how do I check whether donkey is really the correct answer or not? Right now, my area, when I double up my radius, I quadruple up my area, guys. I quadruple up my area, right? And in this scenario here, yeah, 0.3 ohms, because the larger the area, the smaller the resistance, right? I have to, sorry, not 0.3, it's like 0.6 already right now. It's 0.6. Okay, everyone, I might be confusing you guys because I keep looking at the wrong number. We start from the beginning again. I explain why donkey is the right answer, guys. First, we compare the length. 40 cm turns into 80 cm, which means to say the resistance from 0.3 ohm turns into 0.6 ohms, right? This first part everyone understands, right? Right now, my radius from 2 turns into 4. Sorry, not radius, my diameter from 2 turns into 4. And I know that the area for any circle is pi r square, meaning to say when I double up the radius or diameter, my area will quadruple up, right? So from here right now, my area turns into 4A, right? And I know that area is inversely proportional to resistance, meaning to say when it reaches 0.6 ohms, because I quadruple up my area, I'll quadruple down my resistance, which means to say is 0.6 divided by 4, which will give you 0.15 ohms. You're supposed to look at this and you're supposed to look at this, guys. Anyone don't know what I'm talking about? I'll repeat this again if you don't understand. This is important, guys. You are going to look at multiple things in this question, not just the length or the area. You have to look at the radius as well. Oh, sorry, in this case, diameter. Okay, and all this understanding is based on the fact that you remember length resistance is equals to length over area. Increase length, increase resistance, increase area, decreases resistance. How many of you got this question correct? Can I have a raise of hands? Question number 3, how many got correct? Well, only 2 people got correct. And Margie would probably Janelle. 4. 4 out of 16 students. Anyone wants any more information? Yeah.
You learn like original is 2, right? Then if the new one is 6, then you need to
6. If let's say, okay, very good question. So if the original one was 2 and the new diameter turns into 6, you're tripling up, right? You triple up the diameter or radius, your area is going to tax how much?
9.
Yeah.
9.
Yeah, it's going to be
3 square.
Yeah, because it's going to be 3 square, which means to say you're going to get a multiple of 9. If let's say this was area and you have 6, right, you'll have 9 times the area, because here times 3, here will be times 3 square, which is going to be 9. Here times 3, here. Question. Okay, good. Next, potential divider, which I see a lot of you guys don't know. Guys, once again, the potential divider starts with this part here, right? Meaning to say this one here will be 0 volts and here will be maximum volts, right? Remember? Right, remember? No one remembers. Okay, then after they say that the sliding connection at point X is moved towards the top. This thing is moving towards the top. Meaning to say it will eventually point towards here. Right, it will eventually point towards there. And if it eventually points towards there, that means to say this part of the voltmeter is receiving more parts of the resistance, right? And this part of the voltmeter is actually receiving less and less of the resistance, right? So what's going to happen? Right now, I know for a fact that the voltage here is going to increase and the voltage here is going to decrease, right? You just see which one tallies with this information, which is going to be here. I repeat again, my guys, for those who did not catch it, you start with understanding that here is the starting point, meaning to say you'll follow here, and here will be by right 0 volts, and by right here should be maximum volts. It's the starting point of the potential divider. You identify where is the positive terminal of the battery first. And then if I point this thing further and further upwards, right, this part is actually going to have more and more voltage drawn to it. You can imagine this potential divider as a way to split the voltage between these two things, right? Meaning to say, whichever one takes up more of the resistance is actually going to draw more voltage from the battery as well. Meaning to say, right, if let's say I was pointing here originally, here will be 0 volts, and here will be, if let's say here was 10 volts, here will be 10 volts. And as I point it towards the middle here, right, both will be 5 volts and 5 volts. And if I point towards the top here, right now, this thing will give me the 10 volts and this thing will give me the 0 volts. You get what I mean?
Wait, so
yeah.
So basically, I'm saying this arrow, right? The higher it goes, right, the more voltage goes. Like let's say, this arrow goes up, right? That means the more voltage here. Arrow goes down, and more voltage here.
No, exact opposite. Alright, listen up, boy.
I just came loud.
Listen. You start. The whole idea of doing potential divider, right, is by identifying where does it start first, right? You follow this trail and you understand that here is 0 volts and here is maximum volts drawn. Okay, and then right now this wire is in between these two things, meaning to say you can imagine like this is the real estate for this one and this is the real estate for this one here. If let's say, for example, my wire is connected here right now, my real estate here is smaller than here, right? Which means to say this one will get 0 volts and this one will get the maximum volts right now. Okay, but if I point towards the middle here, like the diagram, right? Because it's exactly the middle, right? Here will get 5 volts and here will get 5 volts. They'll split evenly. But if I continue to move the wire upwards, point it all the way here, right now you see this, there's more real estate here, right? So you can imagine that this thing has maximum voltage right now. And because there's nothing left on the resistor, this will get 0 volts. You get what I mean?
Yeah.
So if I have lesser space, then you'll get 0.
Yeah, correct. You can imagine it that way.
So
but it once again has to start with this the understanding here. Okay.
So the more resistance, the more voltage.
Yes, of course, because voltage is directly proportional to resistance. Make sense?
Why is the area I'll say there's no jam on?
Everyone is complaining. I think it's because everyone is doing good thing.
Go and think through what for one of.
Gamble your life savings away, bro. Then you blame Uncle Lim. You know what happened that night? One guy actually gambled his entire fortune away, and he took his car and ran it into the cemetery of the late Lim Kok Tong. Lim Kok Tong is the owner of the thing, by the way.
Bro, ain't no way.
How you won all his money?
He lost all his money, won all his money, still go ram people's grave.
No, you won his money.
Fucker. Hey, would he be working here if you want all his money?
If I won all of his money, I wouldn't be so nice already.
Shit.
Okay, anyways, moving on. The student sets up this circuit. What's this thing called again?
Buzzer. No, sorry. Variable resistor.
Variable resistor.
The mixer.
How do I know? Look at this thing. What's this thing called again? A hockey stick. The hockey stick is the thermistor, guys. Thermistors, the resistance will increase when the temperature decrease. They're always opposite of each other. What's the purpose of this thing?
To sound a bell when temperature rises.
Yeah. You know why, right? Because when the temperature rises, the resistance drops. The resistance drops means to say that there's going to be more current flowing here. And when there's more current flowing here, and so on.
Yep. Me is looking now. You know how much we got?
70, bro.
Just not enough for a Starbucks, sadly.
But if I drew the thing, I get 74. At least I didn't draw it now. If I'm too close, I'll fire.
Okay, the lamp, the diodes, and the batteries of the circuit are identical in the circuit. In which circuit does the ammeter give the greatest reading? Greatest reading ammeter means to say I must have the lowest resistance, right? Which means to say I don't want the current to flow through so many things, maybe. So let's look at it one by one. Right now, the current flows here, and the current flows here. Okay, can. Right now, the current flows cannot flow here, and the current can flow here. Okay, this one can, this one cannot. This one, the current flow here, the current cannot flow here. Okay. And this one, langsung tak boleh flow. Langsung tak boleh flow. So this one definitely impossible here because it will be 0 voltage, 0 amperes here, right? Right now, B and C are the same. Guys, a lot of you guys may ask me this question. I never circled B or C, by the way. Why C? Did you? Why C? Why not B? They're the same thing, by the way. Let's assume, right, guys, I put some numerical values for you guys. You remember this? Let's assume, right, every lamp is 10 ohms. Okay, 10 ohm, 10 ohm, 10 ohm, 10 ohm, 10 ohm, and 10 ohm. Okay, a lot of you guys have the same mentality, thinking that, hey, right now current can only flow through one resistance, or this one current can flow through two resistance, or so this one must have lower resistance and thus more current, right? It's not true, guys. Why? Because as you could recall, the resistance in the parallel circuit is actually 1/10 plus 1/10, which means to say this whole thing only has a total of 5 ohms effectively, whereas this thing has 10 ohms and this thing also has 10 ohms. So because of that, you can see that these two have high resistance and thus has lower current, guys. That's why answer is A here.
Went to Pavilion recently, actually. Wow, so fucking packed up. Pavilion like 人山人海. It's not even enough to describe Pavilion. Past few like this 4 months, right? Pavilion.
What's Uncle Roger?
Before Uncle Roger was Hoyo Fest.
I saw a very bad comment online saying Uncle Roger's food was dog shit.
I mean, it's $18 for fucking fried rice.
$18. I saw $29.
I saw 24. 24 for fried rice.
29 for unagi topping. They add unagi to the fried rice.
Was it good? Anyone tried Uncle Roger's yet?
Oh.
I don't got the money for that.
And this question, we actually done it in the exercise before.
Yeah.
How did you get this question wrong?
Oh,
I didn't memorize the answer. I forgot to memorize the answer.
You know what's this question or not? What's this thing? What's this thing first? Tell me what's this thing.
The circle thing. What is it?
What's it? What's this thing first?
EMF, like the
Oh,
like your finger go in.
Yeah, you know what's it called?
No, so is it this one?
What's this thing called?
Your thumb.
Yes, I know this is the thumb, but what does the thumb represent?
The current, the current going
The
in.
current, the current going in, what will be generated?
EMF.
No,
No. Electromagnetic no man.
no. What's these 4 fingers?
Wow. Direction is clock. I get clock.
Direction of what?
Direction of current. No current.
This one current, this one also current. Shut up.
Direction of electric field. Electric magnetic field.
Not randomly guessing. It's a magnetic field,
I
guys.
just said yes.
EMF is not the same as magnetic field, bro.
Electromagnetic field, no man. That's what I said.
There's no such thing as electromagnetic field. It's electromotive force only. EMF. EMF is a battery or the power source in a circuit.
That's a good excuse.
Okay. So right now I know that the current is going in. Current going into the paper, and I'll have magnetic field that is going to go in a which direction?
Go to the clock. Wow.
Clockwise direction, right? And I even draw this damn diagram during your exercise as well. And some of you guys, not just some of you guys, a lot of you guys got it wrong. So
the answer is A, right?
yeah, it's A because the compass, which is a weaker magnet, will be influenced by a stronger magnetic field. You know this one is related to which one or not, by the way? It's related to the, yeah, it's 4.1, the, wait.
Hey, you ask the mom.
It's literally this thing, bro. It's literally this thing. Why this thing point this direction? Why this thing point this direction? It's because it's being affected by the stronger magnetic field, right? Wait. Oops.
Uncle.
Yes, you are.
Yeah, it's over. It's my major over for you.
Which part are you confused, bro? Which part?
Is it like you look at this, right? Look at this. Let me try to explain. It's okay. Can you like draw like I'll try my best. Let me try my best to explain. As someone who also got this question wrong. So like you see the diagram, right? Where is the arrows heading on us?
China.
No, like it's going to the right? And it will go like you go this one, right? It will go like this, right?
Yeah.
And what arrow is facing this way? Like, look at this, like only A is facing the same direction, like that is the most similar direction to where like the magnetic field is facing, right? So you tell me, where would it go? Like, if it's under the influence of a strong magnet, where would it go? Like, okay. Let me try to. I'm so bad at this game. So imagine now you see a circle. Look at my paper. See circle, right? It goes this way, and A, right, is going this way, right? You see, right? A is the closest direction to where the magnetic field is going.
Yeah.
So, right, I ask you, if this one is stronger than this one, right? It will influence it, right?
Yeah.
And you want to like make it go in the same direction, right? So I ask you, is D and this one the same direction? No, right?
The answer was B some more.
I thought it was very, very short.
Funny, are you uncle?
Yes, you are very, very funny.
Shock,
You understand or not? Seriously, if you don't understand, you better say something right now.
I think I cannot because you go back, so it goes to A.
Okay, I make it super simplified. Right now, there's a current flowing here, right? The current is going into the paper, right? If there's current going into the paper, it will generate its own magnetic field, right? Right. And this magnetic field has a few, not just one circle of magnetic field, right? It will have a few circles of magnetic field, right? Right. Only one of these A, B, C, D will align the compass with the magnetic field, which is going to be A. Yeah.
So it's not going to be attracted to the wire.
No, of course not. The wire only has current.
But my thought process is, oh, the meter don't want to do that. I literally drew the angle of the left.
Yeah, I think I saw you drew it. Saw you drew.
You gotta use the finger method. You gotta finger the paper. Just point it. You gotta shove your fingers.
Yeah. So basically what's happening is this compass that is placed in Q, it will point into the direction of the stronger magnetic field because it's being influenced by the stronger magnetic field, which in this case here is the circle.
Circle is going right. This
Yeah.
one is not inside the line. This one is inside the line but going wrong direction. This one not inside, but this one inside going right direction.
And this question, for those who got it wrong, you are not paying attention. I literally said this will come out in your exam, and you guys still got it wrong. How do I know whether it's C? What formula do I use first?
V equals IR.
Okay, V equals to IR. Then after that, R will be equals to
R will be equals to V.
VOI, right? From here, I know that if it's a filament lamp, it's a non-ohmic conductor. What's the characteristics of a non-ohmic conductor in terms of its resistance again?
The resistance and the temperature is directly from.
No. Yeah, it's not direct proportional. In fact, the resistance is increasing, right? I know that non-ohmic conductors, the resistance increase, ma. And if I know that the resistance increases, by right, the voltage should increase more than your current, right? And I said that you should point towards the voltage direction, right?
To be honest, I was 死背 like
B.
I just 死背 only. Sir say just go towards the V. Okay, no.
I tell you, okay, what he says is correct. If you don't understand this right, you 死背. This one usually go towards the V one. Unless they say there's less resistance. The resistance is decreasing, which nothing, I've never seen something like that before. In case they say, hey, the resistance is decreasing on. Which one should it be then? If let's say donkey because it tilts towards the I, right? If it tilts towards the I, it means to say the resistance is dropping, right? But I've never seen that question before. In short, you can assume that, at least to my memory and experience, all of it will always be like this. Yes, it's C. Yes, it's non-ohmic, which is. Sorry? Yeah, if it's ohmic, then it will be B. Do you circle B?
How am I supposed to?
What do you mean? I said this in the class. Filament lamp is a non-ohmic conductor. In fact, I only gave one example of a non-ohmic conductor, which is a filament lamp. I even drew the stupid circle thing and I told you the dumb story of me spitting into it. Remember or not? Bam!
It's a filament lamp is confirmed non-ohmic.
For sure.
Then not if they ask normal lamp, it's B.
Normal lamp, you mean LED? Yeah, it will be B.
Any other special lamp?
Then the genie, the lamp.
I think that's not even a line.
The only ohmic, non-ohmic only, which will usually be B or C.
Later paper got a picture of
It's not it's B. Ohmic.
No, ohmic is B, brother.
No, it's constant.
It's constant.
Is it B? But this one is the inverse resistance, you know. If you have a straight line, it's a constant resistance.
Ohm's law. Wait, like the difference. Go. You remember? If you don't know, I just physics teacher. I thought very loud, very good one.
Your physics teacher has taught you before.
No. I think I went to teach
Shut up, like, yeah, this fit. Yeah, right.
Yeah,
right. Hey, but was after the exam, bro.
You got teach before the exam.
Okay, shut up, listen up, move on. Okay, a student uses a circuit shown to determine the resistance of two identical resistance. The voltmeter is 2.2 volts and the reading is 0.25 amperes. With this, what's the first formula I use?
V equals IR. And 8 divided by 2 because there's two resistors.
Yeah, a lot of you guys circle donkey, right? Good. Right, but there's two resistance here, means to say it'll be 4.4 and 4.4 each.
Oh, that's the I'm so fucking retarded. My small ass brains, but brain. Hey, I could have easily gotten 80, but I made so much careless mistake before that.
Huh?
I could have easily gotten 80, I'm pretty sure.
Yeah.
True, I made so many careless mistakes.
Okay, next, an electric fire, you don't need to care whatever it is connected to a 2.4 volt supply and a rate of 1.0 kilowatts. Can use one in this calculation.
1000.
Is 1000. It's the same like 1 kg is equals to 1000 grams. 1 kilowatt is 1000. Very good. Anyone use 1 hour for a time? We use 1 hour for time, congratulations. So we must change it into seconds. How many seconds is 1 hour? 3600. Then you can do your calculation. They ask for charge, right? Charge is Q. Q is equal to IT.
Yeah.
Which in this case here, you're supposed to find your I first.
And find I equals to T over Q.
Yeah. I equals to what?
Q.
Oh, you're looking for Q right now. You can't find.
V equals W over Q. No, I literally did that now.
W over Q.
Yeah, so I literally did that.
Can also?
I see.
Can also? Okay.
Where did this shit come
Okay, like I said, in electricity, there's multiple ways to do it. For me, instinctively, I would have thought that, okay, listen up, this is my method. There's not just one method. For my method, is instinctively, they ask me for charge, right? I know it's Q, then my first formula is Q equals to IT. Since I have V and I have P, right? Then I know that P is equals to VI, right? Then I will equals to P over V, and I'll find the I here first. And I'll substitute whatever this is here, and I'll substitute whatever this is into here, and I'll find Q. That's one way to do it. Another method that he did was work done, EMF is equals to work done over Q. Right? In this case here, Q will be W over V. So I need to find the work done. Work done is basically power times time, right? Which in this case will be this thing multiplied by this thing. Right? And then your voltage will just be the 240 here. Easy, but both of it will give you the same answer, whichever method that you're comfortable with. How many of you guys got this question correct, by the way? Can I have a show of hands?
The one formula that I forgot is the one formula that I wrote to you for this question. That I wrote Q because IT, where I don't know how to continue already.
You know the formula, but you don't know how to use.
What's next already?
What?
I was looking at the paper, like Q equals
Because he remembers the formula, but you don't know what it's for.
What's next already?
Just remember letters.
Yes. I don't understand their purpose.
Okay, guys. Any questions? Okay, move on.
Wait, Doctor, how are you guys doing?
Oh, sorry, yes.
Honestly, right? I also don't know.
Can.
Yeah.
Only for you.
Whoa.
Joking, guys. For everyone, guys, please, if you don't understand, you need to ask. That's what you're paid for, right? You don't come here to sit and watch movie, right? Want to watch movie, go cinema.
What movie are you watching?
What movie are you watching?
Physics.com.
The tuition, is it a parody of The Office? It's a parody of The Office.
Yeah.
Okay, so you first identify all this information, right?
No, they have Jim Carrey, Kim Carrey.
Oh wait, you weren't doing
Michael and Sing now, Michael.
It's like sleeping away.
Users.
Wait.
Yeah, bro. Wow. Okay, good. Watch the recording if you need to. Anyways, moving on to question 11. A1 and A2 are ammeters, obviously, when switch S is closed. Closed means to say it's connected, not 关 in Chinese. Yeah, which rule is correct? The resistance definitely decreases because originally it was series, right? Right now, when the switch is closed, it is parallel, right? So number one, the resistance definitely decreases. Reading in ammeter, of course, increase because the resistance drop, right? That's as simple as that. stays the same. Can I know why? Yeah. Why?
You are
I also don't know.
my father. Yeah.
Yeah.
Might be wrong drug, bro. You mean you want to take steroids? You still need to take crack, bro.
Yes.
What? The what is going here?
The ball hits
The-
but it doesn't go the ball one.
It will always complete itself, what? So however much current is here, it will always be the same current here.
Start the problem starts.
Oh, okay. But now you know lah, because current will always complete itself one, so it will take into consideration all the resistance. Meaning to say, right, how even if I have an ammeter here and here, right, both of these will be the same because however much it started, it will be however much it ends. Yeah.
So the current increases because parallel all the current equals to each other, right? Is it?
No, the current increases because just now it's the same calculation, right? You think about this 10 ohm and 10 ohm. Before the switch was on, the total resistance is 10 ohm, right? Right now, when the switch is closed,
So
the
1 over
total
10,
resistance, yeah lah, it becomes 5 ohm. Right, because 1 over 10 plus 1 over 10 lah. Right, we should give you 5 ohms, right? At the end.
So resistance decrease.
Yeah, so the resistance decrease. If the resistance decrease, current for sure increases one. Anyone with any questions? Emerald? Good.
100% of okay, really.
I doubt it. A battery is connected to a circuit. It is switched on for 1 minute once again. Then straight away, make it a habit, guys. You see the word minute, you change it into seconds because, oh shit, this one is 1 minute. Okay, never mind, no need to change. During that time, there is a current of 0.1 ampere, sorry, 0.4 amperes, which is actually current and supplied with this amount of energy, which rho gives the charge that passes the electromotive force of the battery.
E equals
So you're looking for charge, right?
E equals
Just Q equals IT.
Okay. V E equals to VIT and you morph it into E equals to VQ. Can also? Because this thing is Q equals to IT, right? Yes, don't play with your phone. Alright, then easy already law. You want to find the charge is basically E over V law, right? Which in this case here 48 divided by shit, why is it 1?
How do you get one now?
Okay.
It's divided by 2 lah, brother.
Okay, even if it's cooked how good.
So yeah, that's just why.
It's all of us are cooked up, even you.
Wait.
What? Why change it into 2?
Nah, it's even you are cooked up. So you don't say us.
It might be also for you. It might be also for you. It's time to retire. It's time to retire already. I think old age is catching up.
Or you also.
I mean, you already have a.
The hell? Hey, I'm really confused. Why is it 2? But this is in 1 minute.
I shouldn't give up.
It's so your
No, just look at my calculation. Like a 2, watch. I watch 5 and answer the form.
E equals to VIT.
This is a real you change to
it's I think it's fast short lah. You know to use Q equals IT here on suddenly.
I know I have no idea too, bro. My neuron just activated at that.
Oh, good. Okay, good. I'm not reading the question properly. Very good. So,
It's a trick question, guys.
yes.
You all pass the test except for you.
I failed this test, guys. Guys, I because I keep emphasizing 1 minute, but in reality, the calculation for joules is actually in seconds, so you do have to change this into seconds, guys. Right. Good. 3 of you guys passed the test. I failed it. So from the first information here, because I have E, I have I have T, I can find V first, right? Which will be 0.4 multiplied by 60 ma. From here, you'll get V equals to exactly 2. So for sure, it's going to be between this and this already. Then right now, I want to find the charge, right? Charge, I can use multiple ones. I could even use the V equals to work done over charge formula. And charge would have been work done over V, which in this case here will be 48 divided by 2, which will be 24. Which will be 24. Then we see. Yes.
Sigma or something.
I
Good.
think that this is 290, but I don't know.
Yeah, it doesn't matter.
That's
My
not
brain was jamming just now. That's why.
Computer crash already.
Computer crash.
Blue screen a kick.
Guys, I think his brain might crash.
What if I told you that I actually don't know anything about physics and I've just been like scamming your money all this while?
I mean, yeah,
I mean, you're good at it now, so continue.
I'm a good faker.
It's a very good con artist.
So continue at it.
Wow, you fooled me, bro.
Con artist looking up, bro.
Okay, guys.
So the con artist will be very funny, huh?
Anyone?
So that's the case, then you might as well hire 3 of us out. We also try to fake.
Okay, what subject you want to teach next?
This what?
Astrology.
Chemistry,
Economics.
economics, accounting. Who's gonna take accounting? ICT who wanna take?
We don't have the facilities for ICT. We don't
Bring computer.
Yeah. You don't have to use your Wi-Fi, right?
At the time.
Teach you how to set YouTube channel.
Hey, actually, I would love to do
How
that.
to play Valorant.
Okay, next. The end of 3 metal rods are tested by holding NQ of rod one close to the other in turn. Okay, so right now I have this thing that will be attached here and attached here. The end of 3 metal rods are tested by holding Q.
Hey, I thought that everything is a charge, right? I don't
Yeah,
think so.
okay, it's anything lah, right? So the results is as follow. Q attracts R. Okay, this one is okay. Let me redraw it again. Q attracts R. Q attracts S. Okay, if both sides is attracted, that means to say, is this possible to be a magnet?
No.
No, for sure, this is going to be some kind of metal already because both sides also attracted. And Q attracts T, but Q repels you. Right now it repels you already, right? So means to say, this is definitely going to be a magnet, right?
Yeah.
Which one of the metal rods is a magnet? Only rod 3, lor. What the hell?
Huh? 1 and
sorry.
3, bro. Hey,
1 and 3. Now you start to catch a glimpse of my weakness already. Actually, I don't know anything. I'm just here to play pretend only. I'm here to play pretend, bro. Okay, which diagram shows the pattern and direction? Okay, this one I was very lenient because in my opinion, I think that A and C is acceptable. So some of you guys may have circled A, some of you guys may have circled C. Both of it I also give correct. But one of you guys or some of you guys circle donkey. You are the real donkey here, my friend. How can you circle donkey, bro? This one is like when I mark your paper, I saw donkey, I flip back to the front. Die lah.
I need to see because they intersect.
Okay, actually, right, for me, if I want to be very, very strict, actually the answer should be C. Why? Why? Because, right, if you think about it, right, in terms of the density of the magnetic field, guys, the closer they are, the stronger they are, right? But which makes sense, the closer to the magnet is actually the strongest. So actually, if I wanted to be very strict, C is the only acceptable answer. But I accepted A because it's still in the correct direction, and this is indeed the pattern of the magnetic field. But in your exam, guys, just to be safe, if you are ever asked again in this kind of situations, you must know that C is the only real answer here because this one here represents a stronger magnetic field because it's more dense. You know what I'm talking about?
Yeah.
How cannot be weak one?
Bro, it's the closest to the magnet already, bro. You got play with magnet before or not? It's like you place two magnets very close together, you
Ah.
can feel very strong attraction, right? You pull them slightly apart, you don't feel as strong as attraction anymore, right? Because this part has the most amount of magnetic field, which
You know,
means
I
to say
play-
the strength of the magnet is the strongest
I
here.
played the Japan bullet train, very fun in Japan.
Understand or not?
Sure.
Okay, but I accepted A as well. So for those who circled A, I gave you a correct answer also. But those that circled donkey, I want to emphasize again, donkey or B lah, you are the real donkey here.
Never, hey,
And so the donkey got Starbucks lah.
The donkey got Starbucks, but from Kubanan.
Hey,
The star is spelled like this, star. Starbucks.
Starbucks.
This one, this star.
Hey, Mr. Ma, the chocolate is dirt lah.
That's
Java
donkey
is all dirt inside.
shit inside.
The next question here. That's that. Anyways, this round, I owe three of you guys Starbucks, you, Janelle, and Michael. Michael scored an impressive 70%, which was a huge improvement. Although he did not reach the 75 threshold.
Improvement also.
You are.
Improvement from zero.
Shut up.
Before I do this test, the
Shut
paper is
up. Shut up. 70, you definitely not get it because I'm expecting more from you.
Go to 70s.
I see. Yeah.
Okay.
Okay. Hey, guys. I came to this. Oh, this question also gave me a bit cancer. Also. Some of you guys dare to write like that, or here lah, or wherever. Wherever. Wait, this is the first thing I teach you guys, right? Which you are uncertain now, right? You're uncertain, right? You can have done the smart thing and you just scroll all the way to the top, right? Which part you see the voltmeter in here?
Hey,
Which one?
that's what I did.
Which one? Hey, you guys
I did.
literally. Wow. And it's not just one of you guys are like, damn, a lot of you guys. I did do B on a series circuit like that. Whoa. For those who are new here, then okay lah, I can accept, right? But I see some of you guys that were here for the longest time.
None of us are serving.
None of us. Need the marks.
Okay, I want to emphasize again, guys, ammeters are the only one in series, and voltmeters must be in parallel, guys. For those, some of you guys didn't even draw this line, I also gave you your mark. You're supposed to connect a wire here, guys. This is your real drawing,
Nicer than my school teacher, are you?
Hmm?
My school teacher, she'll probably like rip the paper. Why is the line missing?
What?
Well, actually, this question,
Guys, let this be a lesson. Ammeters always in series, voltmeters are always in parallel. If you drew the voltmeter in series, let this be the last time you do it. Okay, then moving on. I got full marks for this.
you know, this also was playing my feelings, man.
So-
You took the paper, it's like,
Yeah.
it's playing my feelings.
Because you managed. Oh, okay, one more mark for you then. Okay, guys, then after that, they said the circuit is completed. The current in the 2 ohms is 2.5 amperes. Guys, when you deal with these kind of questions, it's best if you draw your information on the diagram so you can see what's going on. They said that the current in the 2 ohm resistance is 2.5 amperes. I mean to say here is 2.5 amperes. And they ask you to calculate the current here. They want you to find the current here is how much. Right. So how do I do it? What's the EMF here? Got
They only tell you the.
Oh, actually no need also. Okay, guys. Okay. So right now, this is the first approach that I got wrong, guys. Right now, I'm thinking that, hey, I need to find the current here. I must be given this, right? By right, if I want to use the V equals to IR formula.
Being so easy,
Right.
man.
But right now, as I scan the question, hey, there's no voltage off. Meaning to say this approach is wrong. Right, I cannot use this method. So right now, I need to think about how to find this information given all this information I need. Which how? How should I do it?
Step 1, find total resistance.
Total resistance, no.
The resistance of these two.
I go back to basic.
No.
V equals IR.
Of? V equals to IR of what?
Congratulations, when you play yourself.
What times what?
2.5 2
Very good, guys. What he is doing right now is he's finding the individual voltage of the 2 ohm, the individual current of the 2 ohm, and the individual resistance of the 2 ohm, which in this case here, it will be 2.5 multiplied by 2 ohms, right? Which you'll get 5 volts here, right? Then I know that here, if I put a voltmeter here, it will be 5 volts, right? Then after that, what's the next? How do I relate this to the next step?
5 volts as well because it's a station.
It's going to be 5 volts as well because they are parallel to each other, right? As long as they're parallel to each other, they will get the same voltage, ma. Then from here is the V equals to IR individually again, no, right? Which in this case here will be 5, I, and 4, right? Which you press in your calculator, you'll get 1.25 amperes. There's one more way to get the answer. One more way to get the answer straight away. How can you get 2.5 as the same one? Right now, 1 2 ohm, 1 4 ohm, 2.5 also. Hey, one more way without any calculation, right? I can find the current here.
Use the answer, oh. Use the answer script. Oh.
Divide by 2. Why? Very good.
Your other two.
Guys, listen to what he said. He said, this thing right now, the resistance double up, right? If the resistance double up, it means to say the current should double down, which will give you 1.25 straight away already. But you cannot do that here because it's a 4-mark question, so you must do the calculation. It's just, for me, if I look at it, I straight away see, oh, double the resistance, double down the current, then you'll get the answer already. Then you slowly think about how to do the working, which was what I showed you just now, guys. This one here, and also this one here. Wow. Anyone don't know what I'm talking about? This is important. Anyone wants me to repeat? Yeah, okay. Okay, right now, the working here is, I'm given this information. Okay, if you scan the question, it says that 2.5 amperes is running through this 2 ohm. Right? Okay, then I will find the individual voltage on this line first, which is V equals to IR. Okay, because I'm finding the voltage of the 2 ohm, I'm finding the current of the 2 ohm, and I'm using the resistance of the 2 ohm, which in this case here will be V equals to 2.5 amperes multiplied by the 2 ohm here, which will give me a total of 5 volts. It's 5 volts. When it's 5 volts already, I understand that this line and this line is parallel to each other. Okay, if it's parallel to each other, it means to say the voltage will be yes, it will be the same. It will be 5 volts here as well. Once I have this individual voltage and individual resistance, I can use the Ohm's law formula again, but this time for the 4 ohm, and the 4 ohm. I'll be able to find that current of the 4 ohm is equals to V over R, right? Which in this case here will be 5 divided by 4, which will give you 1.25 amperes. And that's your answer here. The answer is 1.25 amperes. Hey, for the 4 ohm or the 6 ohm? Shit, that's not the final answer.
Hey, why are you testing yourself so many times?
Hey, what I say, the five total.
Yes, okay, then after that, right now, right, I know that this thing is 1.25 amperes, right? I thought the question wants the current here, but that's not right. They want the current here. Okay, I want to know how much current is here.
Wow.
If I have this already, it's very easy, right? Because listen up, the 2.5 amperes is going to flow through here. And the 1.25 amperes is going to flow through here, right? It means to say these two currents, they actually combine together, right?
4.
Yes? 4 needs to 4.
I'm testing you, man.
Did I pass?
Yeah.
Which will give you 3.75 amperes into this thing here. Because I'm plusing both the current. This current plus this current plus together to become 3.75. That's your final answer.
What?
No, I picked that value in my calculation, but then for some reason I continue.
Yeah, I think I saw your working. I don't know why. I think I gave you a full mark
I use
also,
a
right?
completely different method.
Did I give you full marks for this one? I think half the marks. Really?
I use some magic method. I didn't even use whatever circuit I did. Not that.
What did you use?
Like I did
Ratio.
Then I don't even know why I was doing here. Like I don't know my thought process.
Okay, I'll give you one more mark.
So it's talking about what?
resistance.
Yeah, it will matter.
So
Yeah, what?
look at my method, completely different figure. So dumb, right? Even though I was like smoking on much crack already on that day.
What do you do after finding the total resistance?
Oh, I use ratio.
Wow, you're lucky, man.
I'm very lucky. Feeling lucky today.
Right?
Yeah, and dark matcha. Go ahead.
This is not the right working.
Oh shit.
Go dark matcha.
Okay. Wait. Then will you not get the Starbucks?
It's okay. Yeah, follow this method. Your method is not right.
Oh, but you know that I just lucky and got correct.
Yeah, you're lucky.
Even if you dark my matcha, I'll still get 75, right? 75%.
Yeah,
Three
so
point seven seven, 3.8. That shit is lucky, yeah.
This is like
Yeah.
a curry got sample.
Hey, actually, yeah.
Wait, let me double see. Let me double check the method from the Starbucks.
Guys, anyone has any questions? This is a long question. Need to step by step to understand it. Okay?
So let me repeat.
No, because I calculated the part with the 6 ohms. So and then I believe it was 5.
Ah,
Yeah. And then
So my paper is
yeah,
the one that we not on the way problem.
it's the same. Going through and out will be the same. The current will not drop. Anyone don't understand this? Anyone wants me to repeat this again?
Yes, please.
because he realized he was lucky, ma. He wasn't listening the whole time.
No, I was listening. I just don't get it, dude.
Okay, look, right now, right? Assuming that everything is connected nicely already, lah, right? They say that here, right now, there's how much shit? 2.5 amperes of current flowing through here. If you do calculation or ratio, you'll realize that here is 1.25 amperes, right? Because you double up the resistance, right?
And then double
If you
down.
don't want to use ratio, you can find the individual voltage here first using V equals to IR, right? And you'll find that it's 2.5 multiplied by 2, which will be 5 volts. And I know that here will be 5 volts also. If this is 5 volts, then I use V equals to IR again, lah, right? In this time, I will be equals to VOR, which will be 5/4, which will give you 1.25 amperes, which is the same thing, lah. Okay, so right now I have 2.5 amperes and 1.25 amperes already. But the question wants me to calculate the current in the 6 ohm. So means to say I want to find out how much current is flowing here.
Oh, since the current flows like a river, you say then it will
Yes,
go back.
correct. So if you trace the current flow of the river, right, like the river, right, you'll find that the 2.5 will flow all the way until it reaches here, right? And the 1.2 will flow all the way until it reaches here, right? And that means to say they'll plus together. In other words, it's 2.5 plus 1.25, which will give you 3.75. Makes sense. Makes sense,
So,原来是这样。
Makes sense.
Yes. Deciding.
At the same time also.
Okay, then after they ask you to draw a diode. Hey, what was this question? Shows the same electrical circuit with alternating current power supply, AB. So right now there's alternating power supply, means the current will flow here one round, and they'll flow the second here one round, right? Then I say that on figure, we're going to draw a diode on one of the gap of the straight line to indicate a Y on the other. So the current flows from right to left. From right, oh shit, from
What?
right
Another
to
test.
left of the 4 ohm. So this is right and this is left, right? So you just need to draw the diode, right? Shit.
What again? It's why so many tests are today asking us.
Oh, Sleepy Joe, wake up.
My brain is not
Sleepy Joe.
Sleepy Joe.
Oh, Sleepy Joe, tonight Donald Trump debate, wake up,
cannot already have tonight.
Sleepy Joe.
Brain not functioning today.
Sleepy Joe. Go back to sleep, Sleepy Joe.
This topic is a curse.
It's a curse.
It broke my Starbucks streak.
Actually, Speaking of street, today is my 100th Duolingo day.
Which language?
Japanese.
Kawan.
Okay, straightforward, easy, no questions on this one. Yay. Oh my god. Describe what an electric field is. I've seen some really creative answers here.
Give
on
example.
the- Guys, I've told you how to remember this, right? Whenever you think about electric field, you think about the positive charge, right? The positive charge, why is it going out like this? Why? No?
No, it's because people go away from good things. Is it?
Yes, good. Usually people will automatically leave good things, but how did the scientists draw these arrows? What did they place inside?
They place another positive.
Yes,
charge.
they place a very small positive charge, right? And when they saw place this small positive charge, they observed the force acting on the charge, right? That is why the answer will be
Electric field is a region where
region where electric charge and electric charge, which is that small positive charge experiences a force, guys. It's literally a region where a small positive charge experiences a force, and you'll get your 1 mark already. In fact, it was in the notes, guys. I saw some really creative answers here, guys.
Something like a field that contains electrons. An area that contains electricity. Yeah.
The electromagnetic force barrier that contains protons inside.
Yeah.
The
Okay, done. Okay, then after that, this one, literally 3 months. Draw a pattern. Also, some of you guys do it wrong. By the way, guys, in your exam, when you're drawing this, do you know that you need to have equal spacing? Why equal spacing? Yeah, it's a uniform field, guys. Uniform field means to say it will be uniform strength. Let's do it off like this.
Next question.
Okay, next question, the dreaded milliamperes. 0.12. So for those who wrote a bad conversion one. Oh, this was the one that went to million, guys. 210,000,000. Good. Million. Hey, then I want to ask you this. 1 mm, right? Is it million meter?
Maybe yeah.
Maybe.
If the M is big, if the M is capital, then maybe
If it's capital, then it's million, bro. It's mega. Yeah, mega is times 10 to the power 6, which is million.
Then a small M is what? Milli? Milli ampere.
Yes.
What's that? Milli ampere.
You never thought of the word milli again?
Yeah.
Were you here during the?
I don't think I was here. That's not Facebook lah.
Yeah. What thing? Usually,
So but I didn't go class. I get 70A or I have Starbucks.
Congratulations. Congratulations.
And you think I skipped 2 classes I still got 70, just sigma, right?
Wait. 1 week is 1,000. I never knew this until today. Actually,
Yeah, so quota.
so
am I.
You know, this application is the same as your K and whatnot, like right now.
Yeah, like K I know it's 1,000 lah.
Yeah,
I never seen it in my life.
I wonder why no K is 1,000.
Never seen it in your life, you must have skipped primary school.
Probably
Hey, what were you doing in primary school?
When I went straight to high school.
And you play ping pong with Marlon during
Yeah, I fly to China.
Hey, time to play pickleball already. All big ball, something fun.
Why? Why?
Oh yeah, Mr. Gilbert works in the pickleball club, or you ask him like.
I answer we play all three.
Okay, see you in.
Hey, where's Mr. Gilbert club? Gilbert's the club. Hey, PJ not that far, not
But cars and sales.
And then it's
And one more, we don't know yet.
The pickleball cup is his, by the way. He owns a nice cup as a share.
Hey, that's pretty good.
It's not working.
So you're- Start.
Yes.
Belanja, the other person start up one.
Was like, we are scared.
I'm not good, I'm not good.
Sometimes I bring my own tuition class.
Oh, I got man. Yes. No.
Shut up lah, you try to scare me.
Oh.
Okay, we ask you for charge, right? Very simple. Q equals to IT here. In this case, it will be 0.12, and the time can be done.
10 times 60 times 60 times 60.
Yeah, it's 10 times 60 times 60. Oh, thanks, man. Yeah, press this in your calculator and you'll get it.
It's okay, fine. If I knew this, I get how many? 3 marks.
Yes.
I mean, you get Starbucks.
What's the answer?
Hey, sir. I'm so cooked, bro. I didn't consider like the other. Oh, million now. I forget about that.
What's the answer? Serious?
I'm currently answering the answer.
Oh, no one got this correct.
Oh.
4,320. What's the units for charge? Coulomb, very good.
Guys, Michael's improving a lot.
Isn't it 7,500?
Wait.
Oi!
So you failed the test.
I didn't fail the test, bro. I didn't do the calculation. How do you get 4,300? It's 7,000, eh? 7
My
what?
brother, guys. Guys.
Ah, hey, my brain is jammed, man, today, seriously.
Hey, you want me to buy you Starbucks?
My brain is fried, man, today.
So you want Starbucks?
I feel like I'm sorry, my bad. It was my fault. I chef.
So you want Starbucks, right? Genuine question.
No, thank you.
I give you 6,000 copy. Yeah. No.
Oh my god. Wow, we're not even done with this paper.
Are we cooked?
Yeah.
Sleep not fair.
Okay, we'll finish these 2 questions and I'll let you guys go already.
Yeah, we just go to the hardest question of this paper,
Yeah.
man.
We'll continue this next week, guys.
The hardest question is this one, and I somehow got it,
And we got it. So it doesn't matter.
which is sigma.
Cover energy store. If they're talking about energy, there's only one formula that relates all these things with energy equals to
Unfortunately, I wrote 100.
Can also. It's the same thing. IT is Q.
Wait, so how come it takes so long to discuss paper one?
Huh?
How come it takes so long to discuss?
Because the grade threshold was low, man, this exam. What's the answer?
Not mine.
Is it this one?
151 only.
No, wait, I did some miscalculations for the my fault, original game. So
9 what?
9072.
Oh, and one more thing, guys. I want to mention. Until today, I very tired already. I see. Some of you guys are still writing more than 3 significant figures here. I didn't explain so much already.
Hey,
I say this the last time, guys. You can only write 3 significant figures here. 3 significant figures here. Anything more than this, you'll be minus 1 mark for every 1 question, guys.
Hey, you know what? Mr. The pass.
hey.
What's marked is already marked.
And finally, the energy stored in the battery is chemical energy, guys.
It's not electric energy.
There's lithium inside, right? Lithium batteries. Lithium is the chemical reaction that gives off the current flow. Brain is fried already today.
So do take a break, relax.
Yeah. Okay, guys, I'm gonna stop here today. Bring the paper next week. We'll continue.
It's fine if everyone should take a break once it's like, wow.